All right, and then part C of this problem, they ask you to determine the power dissipated by the 4K ohm resistor, which is right there. So this last part, pretty straightforward, pretty simple. But we have our solutions from A and B, which you can see from the prior videos. So there's actually two different ways to solve this using an iteration of the power equation. So these values here that you see on the actual schematic on the circuit are values that we found. So what are the two ways we can use to solve for this? So one thing that we could do is we can go ahead and for the first one, let's just look at voltage. So for voltage, we know that on one point of the resistor, it's 21 volts and the other point is 25 volts. So what's the difference here? The difference here is going to be 4 volts like so. So we can use power is equal to V squared over R this time, not I times V. You go ahead and convert this by taking P equals IV and then take V equals IR, Ohm's law. And you can go ahead and substitute values in to make V squared over R. All right, so from here, we know that the volt, since the difference is 4, that's going to be 4 squared over 4 kilo ohms, and that's going to give you 4 milliwatts, like so. Alternatively, you can go ahead and use the current. So we know that the current going in to here, into the resistor, is going to be 20 milliamps, and then the current going the opposite direction, as we identified with our meshes from the prior video, is going to be 21 milliamps, like so. We can use the other iteration of power, P is equal to I squared R. So what that'll get us is 1 milliamps. That's going to be the difference between 20 and 21 squared times 4K ohms. And then that will also yield you 4 milliwatts as well. And that's how you finish off this problem.